a potentially life-threatening asteroid hiding in the glare of the sun. A team of international astronomers have discovered 3 new near-Earth asteroids. 2 have orbits that won't intersect with Earth's, but a third, a 1.5-kilometer wide chunk of space rock, could someday cross our path. This comes just weeks after NASA deliberately crashed a probe into an asteroid, the first full-scale test of asteroid deflection technology. With me now is Paul Delaney. He's a professor of physics and astronomy at York University. Paul, good morning.
Good morning, Marcia.
Besides the obviously frightening title, what is a planet killer asteroid?
Yeah, it really does ring badly, doesn't it?
It's catchy.
Basically, when you're talking about an asteroid that is a kilometer in diameter or more, then the impact of that sort of an object on Earth is enough to throw up a significant amount of material into the jet stream to lower the planetary surface temperature, disrupt the food chain, and potentially administer a deadly blow to a significant number of the life forms on this planet. The bigger the asteroid, the bigger the problem. Think back to the dinosaurs 66 million years ago. That was about a 10-kilometer rock, and it destroyed 90% of all life on this planet.
Good grief. So put that into perspective for us then. This one is 1.5 kilometers. How much damage could that do?
Very significant. You don't want this thing to hit us. That's really the bottom line to it, which is why astronomers and others are looking to the heavens continuously to keep an eye open for such threats, and why NASA, as you mentioned, performed DART, that intercept mission, to deflect an asteroid away to show us the capability. 1.5 kilometers is a sizable rock, and it doesn't matter where it comes down, it would cause serious devastation to our planet. So as I say, we do not want that to hit us, and that's why we keep our eyes peeled for them. But finding the objects which are close to the sun, which is where this one is, AP7, is located, is doubly difficult. Looking in the opposite direction is relatively easy. We've found thousands of objects, but looking close to the sun, that's the big challenge, and why this one was a bit disappointing to find.
All right, so how much time do we have, and do you expect that NASA will roll out the same technology that they used a few weeks ago?
The important thing here is that AP7 is not on a collision course for them at the moment. We now know it. We are going to monitor it. We have its orbit tracked, but it's not on a collision course for Earth. But it has the potential to hit us because it will cross our orbit. But it is not expected in at least the next 100 years, because we can't really forecast beyond 100 years. This one is not in a dangerous position for us. If it was, then yes, the deflection technology that we have just demonstrated would be brought to bear on it. The longer in advance you know about the possible threat, the easier it is to deflect it. And so that's why we want to know where these objects are literally every minute of every day.
We've got some time to prepare. That's the good news. Paul Delaney,
Yes.
thank you so much. Glad you could be with us today. Paul Delaney is a professor of physics and astronomy at York University.